Hello, my name is Alicia Bateman and I am studying Environmental Resources Engineering at the State University of New York College of Environmental Science and Forestry. This summer I did research at the Center for Bio-Inspired and Biomediated Geotechnics at the State University of New Mexico. There, the research we conducted was working with Adobe construction and increasing mortar strength by using natural additives and treatments. Adobe is a construction technique that uses natural soils, water, and straw to build buildings. It's a really good sustainable way to construct things because you can source materials locally as well as have very little demolition waste. In testing of Adobe products, it is found that mortar is typically the point of failure for these constructions, so we were working to increase that interface between the mortar and the brick strength. We did that by adding different treatments to the mortar to test how it would increase the strength of those bonds. The different treatments that we used were additives of castor oil, nopal cactus extract, which is a traditional method used in Adobe making, low methoxyl pectin, and also we tried wetting the contact surface of the brick. We tested this in a couple different ways. The first was an offset stack where we applied a load downwards and tested this allowable shear stress. We also used 4-point test on a mortar joint as well as a solid beam made just of the mortar so we could understand the material properties. We used digital image correlation for that process. The results of our findings was that a lot of the bricks were unable to be loaded because that interface was still too weak. So that lets us know that the way we tested things could have been done a little differently with less force applied, maybe using smaller bricks. But the only bricks that were able to be loaded and derive data from were the ones that were wet laid. So that shows us that those were considerably stronger than all of the dry laid bricks, no matter what the additive was. We also can see here in the middle figures that brick 9, which was wet laid, has a very rough surface texture where it broke. That means it broke into the brick and it was able to be much stronger because the brick is a stronger part of the material and that interface was more connected. Brick 11 was a dry laid brick and it broke just like a sheet and there was really no interaction on that interface. We also calculated the modulus of rupture for each of the mortar materials. We found that the nopal cactus extract and the low methoxyl pectin were very similar to the no additive. So they didn't increase or decrease the modulus of rupture. The castor oil additive did decrease the modulus of rupture significantly. So understanding the modulus of rupture can help us understand how Adobe might react to severe weather events or earthquakes, and that decrease in the modulus of rupture lets us know that that's not a great additive to add to the mortar or the brick material. We also plotted the modulus of rupture with the moisture content. Moisture content is very important for Adobe because it will expand and contract the material and cause cracking and failure over time. So we really want to understand how moisture content is being changed within these materials. We found that all of the treatments maintained a similar moisture content except for the nopal cactus extract, which maintained slightly higher. We believe that it's because the moisture content might have fluctuated less in this material because all of the materials were left for the same amount of drying time. In conclusion, the testing configurations that we tried to test the strength of the mortar were too fragile to derive much data from, except that the wet laid bricks were stronger. Because the wet laid bricks were so much better, we should continue exploring that and quantify the benefits of wet laying the mortar. And also the castor oil does significantly reduce the modulus of rupture of the material, so maybe not looking further into that. To continue our research, we should focus on increasing the physical interaction between the interfaces to get a more bonded materials. And we should also understand how additives affect the strength of Adobe at varying moisture contents. Thank you.